Hello, everyone. Thank you for joining us. Today, we will talk about floating solar and more specifically about floating solar and hydropower. For this topic, we will have the pleasure to have a presentation from Ciel Terre, and he will walk us through the challenges and best practices. But before I introduce our very insightful speaker, I would like to talk about the next conference we have coming on this topic. It will happen this year in Paris, and it will be on the 19th of September. For this conference, we have the pleasure to share for until the 15th of July a special discount of 20%. And as you can see, there is the day before happening as well in Paris conference on agri-PV. So if you are also interested in that topic, please join and we will be very happy to see you there. Solarplaza, for the ones that are not really familiar with, we are based in Rotterdam and it's been already 20 years we do exist. We organize conferences everywhere around the world. We've done already more than 200 events. And we have a platform called a website, www.solarplaza.com, where you can find all of the resources we produce, such as this webinar that will be available there afterwards, and quite a lot of other information also on the conferences we organize. Some practical notes before we start with the presentation. All along the presentation, you can drop your questions. We will address them at the end of the whole presentation, and we will discuss. So feel free to put them because they will be answered for most of them. Technical issues, you can also on the top right of your screen where you have the Q&A, you can also drop any issues, and then the team I have next to me that you cannot see here will be answering and helping you. For the presentation slides and also the full recording, it will be available afterwards in the next 1 or 2 days. But now I would like to introduce our speaker for today. It's Stéphane Prouvost. He is Division Director, for Ciel Terre. Hi, welcome, Stephane. But then I would like to say a few words about you first. He began his career in the marine industry and he joined Ciel Terre in 2016 as European market developer. But then he went to India, where he's been establishing Ciel Terre India. And he also produced a 150 megawatt project. And he launched the R&D center in India as well that was focusing on new FPV designs. Right now, he's division director, as we said, since 2021 and co-managing the floating project division worldwide. So now, Stephane, I'll let you take over and start with your presentation. Thank you very much.
Thank you, Marjorie. Hello, everyone. I'm pleased to be connected with you today. So I'm just going to remove the video here. Okay, well, let's start. So today I'm going to speak about the main technical challenges of floating solar on hydroelectric dams. So I'm Stephane. Yes, I'm a division director of Ciel Terre. So first I will briefly introduce Ciel Terre. Then I will go to the risk and consequences of wrong design or wrong execution. I will then speak about the basics of reliable FPV solutions. Then I will jump into the two main concerns on hydroelectric dams. So about Ciel Terre, we commissioned around 300 projects in 30 countries for a total of about 1 gigawatt. We have 600 megawatt under construction, and we started our journey on floating solar 13 years back. So we'll run a quick video now. Just drop me a message if it's not running correctly on your side, and I will just stop it and continue the presentation then.
At Ciel Terre, we know that a sustainable world is still possible if we act now, on a large scale, all around the world. We make it our mission to deploy renewable energies and positively integrate them into the local environment. For more than 10 years now, we've been developing floating solar power solutions from design to distribution and installation. Because we know how much floating solar power has to bring, with its inland water potential estimated at 4,000 gigawatts. By using artificial ponds, floating photovoltaics solves land issues by preserving available areas, making it a smart renewable solution compatible with various ponds types and activities. We believe in the power of cooperation and in the hybridization of talents to implement solutions offering ever greater promise and respect for mankind and biodiversity. It is by working with local partners spread throughout the world that we are able to build solutions that are both bold and diversified. With more than 250 projects installed worldwide, facing so many different conditions, from typhoon zones to high wave conditions, we have gathered a tremendous field of experience and technical know-how. This unique expertise makes us the world leader in the floating solar industry today. But we will keep on taking on new challenges, because we believe in continuous improvement of our solutions. In our own laboratory, we test our product's reliability, setting durability criteria above the market standards and challenging our processes. We innovate with passion to open new, promising pathways, offering ever greater respect for both humanity and biodiversity, striving to optimize our solutions, our advice, our support. Year after year, we challenge our products, our designs, and our mindset to meet new needs, to be more and more in harmony with the environment. We are ready to drive the floating photovoltaic market and deploy floating solar energy for the sake of our future. We know that solar power still has a lot to give, and Ciel Terre has a great role to play. Join us in our human solar.
Yes, Stéphane?
Yes, I'm trying to change the slides. It's not working for me now. I'm blocked.
Okay, we will do it again. Just sorry for the people following us. It's gonna be back on track. Yeah, it's gonna show in a second.
Okay, all
Yes.
good. Thank you, Marjorie. I take the control. All good. So, but Ciel Terre, we did actually 6 projects on hydroelectric dams. The first one we did is in 2016 in Portugal for 200 kilowatt peak. We did another project in 2018 in Japan. It's 11 megawatts called Yamakura Dam. Then we did in 2018 in Brazil, 1 megawatt project called Sobradinho. Last year, we did a project with EDF in France called Laser Dam for 20 megawatt project. Then this year, early this year, we did 7 megawatts in Brazil called EMI project. And recently, we just commissioned a project in India for 120 megawatt project. So now I'm going to speak about the risk and consequences of a wrong design or wrong execution. So first, consequences could be a loss of generation. This could happen due to macro cracks on modules. It could occur when you place torsion on the panel or when you have water splashes. Also, those loss of generation could happen when you have a poor cable management or even a wrong module tilt. Especially when you go for like more than one in a row configuration, because you have extra buoyancy from the maintenance alley. So this could impact the tilt of the floats and then the tilt of the PV module. So the consequences could be also an extra OPEX. This is due to component replacement, such as the PV panel and DC cable. Also, it could happen on string inverter if you place your string inverter on the structure, as well as the PV panel fixation system, for instance. So yes, it could have a significant impact on the OPEX. Also, a consequence could be the water, to have water pollution. This could be due to a wrong polymer formulation, especially if you use a wrong UV stabilizer. We call we have a shocking, what we call the shocking, especially on polypropylene parts. After a certain duration, then UV starting to impact the polymer. And then you have this powdering forming on the outer surface of the part, and those powders are dropping in the water and then polluting. Another thing that we saw, we see competitors trying to lowering down their cost, and by incorporating recycled HDPE or polymers. And as we are using mono layer machines, it means that when you mix it in the virgin material, then you may have contaminants going on the outer layer and then being in contact with the water and having a pollution here. And other consequences will be to have a partial structure crash, and even worse, the full structure crash. Here, just one picture of a project. I think this one is in China. I'm not sure. Unfortunately, we see already too many, and we recorded about 40 power plants being impacted like this, with more than €1 million damaged. This only within the last 5 years. And knowing that it has to last for 25 years, we think that it will even increase. The percentage will increase. Now it's about 4%, but we can extrapolate for 25 years. And I think that we'll have more than 10% of big damage in the coming years. So I just wanted to highlight the risk here. And when selecting the technology for your project, please be extremely careful. So here, the failure point. We see often that the failure point is the connection between the floats or even the connection of the mooring line. Why? Is because you have high concentration of loads. So it could happen on the here. We see a picture of one of our competitors. On the mooring line, we see a picture here of a steel mooring line. And we see after already 3-4 years, if it's not protected correctly, we see high corrosion, and the cables are breaking. Same for the ropes. We see internal abrasion. So in Ciel Terre, we do select carefully the fibers to be used. So what the risk consequences of wrong design and execution? So, sorry, I think it's lagging slightly on my side. Yeah. Okay. Just to say that we need to qualify the product to ensure a good project, quality project. So wanted to say that the theoretical calculation is not sufficient. We need to assess with physical tests to understand the limit of the design, the limit of the product you have. So we see on the top left picture that this is inside our lab. We have a thermal chamber when we do pull tests of -degree up to 50 degrees, and we analyze, we assess the strength of the float. So this one is a small secondary float, but we have main floats, maintenance floats. So we do some assembly also, and we pull to understand what is the strength at different temperature. We see in the middle here that we have a panel fixation test. So here we are pushing and pulling on the PFS. What we call the PFS is a panel fixation system. for millions of cycles. We see that we have all those cycles from the wind, mostly from the wind, also the waves. So we need to analyze what is the fatigue of this fixing system on the float itself. On the top right side, we see here our buckling test, what we call buckling test. So we make an assembly and then we pull, we put the maximum load that could happen during the lifetime of the project to understand what is the deformation. And according to that, we could optimize the anchoring design. On bottom left, this is a wind tunnel test, and this is needed to correlate our CFD because we do some simulations, and we need to ensure that in the simulations we are putting the right parameter. So it's pretty important to correlate with wind tunnel tests. In the middle, bottom middle, it's a bending and abrasion test. This is once again in our lab. So we do millions of cycles with a certain load and certain angle on the float to understand what is the fatigue of the hairs of the connection point, and also to understand the abrasion of the material. On the bottom right here, we see, I will run this quick video. I'm not sure. Yeah, is it working? Yeah. Wow, we can't see much. Huh? Actually, just to highlight the importance of having the right UV stabilizer. You see that only after a few months, actually, we see that the material, which if it's not properly stabilized, it's becoming really brittle and it can easily break. Okay, video is not working. Fine. So yes, even minor change in the design, such as part size and material, has to be analyzed once again. You can't just simply change the design and assume it will work. You need to test. Okay, next slide. I would like to go to next slide. It's not moving on my side. Okay. Yes, this is about the project design. Because first you need to understand what is the limit of the product, but then after you need to adapt the product to the site or see what is the constraints you have at site and making sure that your product could fit for that specific site. So at first you have to evaluate for this site what is the environmental load to be considered. So first, the big one is the wind, of course. So you need to look at the local building code and here to select the right wind return period. So it could be like 300 years, could be 50 years. So this is pretty important to be conservative enough to make sure you're not taking unconsidered risk. So yes, selecting the right wind return period, the right wind speed reduction, because often when you have a wind speed, it's at 10 meter high, but also you need to reduce to the panel height, which is often we consider 1 meter in Ciel Terre. Also, there is one big parameter is the gust wind. And gust wind, we see that it's having a big impact on the wind to be considered. If you go for 30 seconds, sorry, or 10 seconds or 3 seconds, it's having big impact on the wind, on the maximum wind to be considered. So this is for the wind. Also, you need to consider, of course, the waves, especially when you have fetch more than 100 meter. So yes, we see that waves could increase by 20-30% the load on the floating structure. Water current, of course, depending on the site, but this could happen, especially on hydroelectric dam. So according to the maximum environmental load, you can calculate what is the maximum array size. And so when you have a typhoon's area with high speed of more than 200 kilometers per hour, often you have only maximum array size of maybe 2-3 mega. It's becoming pretty small. When you go in a location where you have minimum wind speed, then can go up to 10 megawatts, depend. So we do the proper calculation. When you have a non-regular shape, then you need to evaluate the load concentration. And this is really important. Often you want to optimize the space you have at site. So you try to have kind of stair design. And this is giving more concentration, load concentration on the structure. So we need to carry some simulations. We use it. We do it with Orcaflex, which is a software to evaluate the load concentration here. So when you have all that, you need to select the right component, the right floats, of course, the right fixing system. If you want to clamp the panel, if you want to bolt the panel, yes. So you need to select the right part. And then, of course, to define the anchoring design and the number of mooring line. An important aspect is to, of course, analyze the fatigue at the specific location. So fatigue could happen due to wave, as I just mentioned. I will detail a bit more later on. Also the UV, and the UV, depending where you are, if you are on high irradiation, in high irradiation country, like India, for instance, is not similar that if you do project in Japan or even in Europe. So you need to adapt your formulation, the polymer formulation, to ensure it will last for 25 years. The corrosion is one important aspect. Corrosion, if you have in saline environment, you could have really high corrosion and galvanic corrosion also. If you mix the materials of aluminium, for instance, aluminium and steel, you will have galvanic corrosion. So this is really important aspects to be considered. Of course, we need to consider safety factors wherever you have uncertainties. And in Ciel Terre, we use a DNV from offshore with a safety factor of 1.6. You have different uncertainties when calculating the environmental load. So you need to consider safety factors. And also, you have to consider an accidental case. It means when you have one mooring line failing, you need to ensure that the adjacent mooring line can sustain the extra load being applied on those lines. When coming to the project execution, of course, you need to follow the manual instruction. We see often that there is subcontractors of our customers not always willing to do it. They want to save time or save money, and so they do compromise on the quality here. So it's extremely important. Another point during the project execution, which is extremely important, is to minimize the construction time of each array to avoid temporary anchoring for a long duration. Why so? It's because if you face a high wind speed during construction time, you have only temporary mooring line, and you connect only few anchors, few spreader bar, few fixing points, sorry, on the array. So of course, if you have high load being applied due to mainly the wind, then it will be too high, and the temporary mooring line will break. So it's extremely important to be fast enough to avoid any big crash during installation. Of course, we have to ensure that all components and material are similar than the component mentioned in the datasheet. We see competitors incorporating recycled material during the manufacturing. Why so? It's because everyone's trying to save costs. And so as a customer, you should be careful. You should control what your supplier is doing during the manufacturing. And last point I wanted to highlight here for this project execution is the anchoring. We always control, the anchoring point, the right location. If you're not placing the anchor at the right location, it means you are overloading few mooring lines, and you need to ensure good distribution of the load on every mooring line. So if they are not all aligned, means there is overload on certain mooring line and others are not working. So, and then it could obviously fail due to that issue. So I will go now on the two main concerns on hydroelectric dam. Stop the video. Yeah. Sorry. Yeah. So often on hydroelectric dams, always we see this big reservoir. It's extremely big reservoir. For instance, on the picture here, what you see, this is in Portugal, this Alto Rabago project. There is a really big distance between the shore and the dam, what we call the fetch here. This is 7 kilometers, but often we can see even more. In big project, big hydroelectric dam, we see like 20 kilometers, 30 kilometers, and this lead to big waves, mainly due to the wind, because when it's blowing here, for instance, from east side or northeast side, then you have accumulation of waves due mostly to the wind. So you can see quickly here on this video on right side, if it's working for you. You see a lot of movement, right? Because it's a flexible structure. So, and of course, this leads to fatigue after years. So for that, we need to analyze what will be the fatigues after 20 years. So this is kind of damage that could happen if you are not careful enough, you are not protecting the array, the structure itself. So we see important abrasion happening on those screws, what we call the connection pin, and also on the connection point, the ears, which are connecting the floats together. Also, we see cracks happening, cracks on the ears. So because you have compression stress on the upper side and tensile stress on the bottom side. So when you have millions of cycles like this after years and years, yes, the material getting damaged with too much stress on it. So yes, this has to be analyzed also. Going to the, sorry, about the wave fatigue here in Ciel Terre, what we do, we try to predict what will be the damage. So we consider the inputs from site, so the wind speed, the wind direction, the wind occurrences, and the associated fetch. So according to that, we can evaluate what is the wave spectrum, and then calculate the float movement and angle. Thanks to our lab fatigue test result and experience we have on other FPV installation, we can predict the damage. So we see on the bottom left here, we see the number of cycles. This is what we do in our lab with a specific angle, and we see how many cycles we can apply before the ears are breaking. This is the simulation we are running. So this is a small assembly. So we, depending on the period of the wave, the length of the waves, we see that it's behaving differently. So that's why we run simulations to understand how it is penetrating in the water and what is the angle of the floats. So here we have, well, it's moving. I don't know. Yeah. May I go back? Okay, we try to. Okay, let's see. Yes. Okay, and here we see is our lab. Here where we have a machine. Okay, let's see if it's running. Okay, so we have yeah, this here. So we apply millions of cycles on float. So we connect floats together, and then we have a piston where we apply millions of cycles with a certain tension on the float, and this to understand what is the fatigue with a certain angle and certain number of cycles. Okay, here on the top left, this is the wave pool test we are doing on our, because we do develop specific wave breaker here. So that's why we do some wave pool test and also simulations here you see on the top right side. And we need to correlate both, because when you do a simulation, once again, it depends on the parameter you consider for your simulation. So it's not sufficient to do only a simulation. You need to correlate with physical test. So with that test, we can define what will be the transmission coefficient of the wave. So depending, once again, on the wavelength and wave height, we can define what is the transmission coefficient. Okay. Of course, when designing a wave breaker, there is a different parameter to be considered, as the pattern configuration, the draft and the depth. Also, of course, the weight of the wave breaker is having an impact. So we do consider all that when designing our own wave breaker. Why in Ciel Terre we design our own wave breaker is because it's difficult to find competitive floating wave breaker, and to have good efficiency also. So that's why we decided now 3 years back to develop our own solution in Ciel Terre. So the second challenge for hydroelectric dams is the anchoring. First, we have high water depths. So when you have high water depths, you can't use normal technique, I would say. We used to do anchoring from the top surface, having a barge and placing screws with a mast from the barge up to the bottom of the reservoir. And when you have high depths, you can't use those techniques. So, okay, I don't know, it's moving. So that's why you need to use robotics, and for that, it's a bit specific. So it's complexifying the process. Also, the high slope. Hydro dams are often placed on what used to be a valley. So you have high slope at site. So placing a big dead weight is not reliable. We see that it's sliding when you have a high slope, of 20 degrees or even more. Then with the tension on the mooring line, it could slide the dead weight. So you need specific technique. In Ciel Terre, we screw or we rock bolt our anchors to avoid any slide of the anchoring point. Another aspect is the water level variation. Of course, this will have an impact on the displacement of the array on the top surface of the reservoir. So either you accept a bigger displacement of the array, or you need to find specific techniques to stabilize the array. So this also could have an impact on the maximum capacity you can place on the water body. Another point to be considered is the rocky, I would say the rocky environment, is because you can't just screw into the ground. That's why also we developed our rock bolt technique. So we are drilling into the rocks to ensure that the anchoring point is safe, and then we can achieve really high load. So here we had to develop our own tool to do such a thing. We are using a robotic going down to the ground, and then we drill in the rock. Another thing that we need to consider when doing hydro floating solar on hydroelectric dam is the trees and the dead trees. Recently, on the project we did in India, the 120 megawatts, we see there's many dead trees still in the water to the ground. So we have to be careful because it could affect the mooring line being in contact, so it can lead to abrasion and also concentration of load if it's not having a straight connection. So this is something to be considered. So one last point, which is pretty important to consider, is the uneven bed of the reservoir associated with the water level variation. Why so? It's because, for instance, here on the right side, you can see the picture. When water level is high, then you see that you have good repartition, good distribution of the load on both mooring line. But when water level is going down, then you see that the bottom line is getting loose here. Means you have more load applied on the top line. And if you have too much concentration of load here, then it will fail. So this is extremely important. So we do complex calculation, and we use specific software to define where is the right location to place the anchors. Okay, I will go to the conclusion. So of course, FPV on hydro dams is surely a great idea, and especially because there is a limited potential on hydroelectric dams. It's such a big water surface that we can make gigawatts of project there. However, there is many technical challenges to ensure the integrity of the structure for 25 years and even more now. Sorry, not yet finished. Then to define the right floating structure, we need a proper fatigue analysis. This is extremely important. Each site are specific, and we need to carry proper analysis and studies. And final point is when the distance between the array and the shore is big, the installation of a specific wave attenuator should be considered. Okay, I think that's it on my side.
Hey, thank you very much, Stéphane. So now it will be time for the Q&A. So if you have questions for the ones that joined us during the presentation, you have a chat box on the top right of your screen where you can drop your question, and we will try to address as many as we can. We already did receive quite a few. So I will start with the first one, Stéphane. So how important are geotechnical studies for the anchor points, and are pull test and tensile test of the mooring lines sufficient without obtaining subsurface soil properties?
Yeah, of course, it's needed. We always ask those data when starting designing the anchoring solution. Still, even when you have geotechnical and SPT, what we call a soil penetration test data, still it's always good to make a test, a trial at site to understand what is the exact load you could apply on your anchoring point. But yes, of course, it's needed to evaluate the feasibility of your project. So that one of the first information we always ask.
Okay, all right. So we also, so you presented a slide that was on the anchoring challenges. So you have developed a vertical mooring system. That was the question.
Yeah,
have you developed?
It's not vertical one. Sorry, maybe I was not clear. we developed a system where we could drill into the ground and especially into the rock. When you go on hydroelectric dam, often it's a bit rocky environment because it used to be a valley when you used to have after current from hydro dams. So all the silt and the ground has been removed, and then only the rocks remain there. So we developed a system to drill into the rock to place our anchors. So it's not a vertical mooring solution. No, we accept a certain angle of the mooring line. If you have too much vertical load, it will sink the edge of the array. So we do calculation to understand what is the vertical load applied on the array, and accordingly we do we optimize the design. We could add extra buoyancy on the edge of the array to avoid any sinkage of the edge. Yeah.
All right, thank you. So now other topic. So it's still on the mooring loads. How big are the mooring loads, and are the anchors for rocks installed by diver or a subsea drill rig? And how heavy, and can it work on slopes?
Yeah, it's a good question. We're still optimizing our system. It's quite new. Huh? We started to have this technique. We developed this technique a year back. So yes, on slope is even more challenges because we have kind of tripod which we drop down on the bed of the reservoir. So when you have a slope, then you need to stabilize the tool. So it's even more complex, but feasible. So yes, we could do rock bolt on the slope. That was the question, right?
Yeah. I
Can
mean,
you repeat, Marjorie, once again? This was
yeah,
one
I
the
can
slope.
repeat the whole question 1 second because we get quite a lot of question coming in for you. So yeah, so how were they installed, and how heavy, and can it work on slopes?
Okay, slope we can do. How it works is a bit complex. We drill. It's coming from offshore industry, from oil and gas techniques. Oh, yes, but we had to adapt for smaller anchoring. Yeah, it's a bit complex, and this is our internal development, so we can't communicate too much. Yeah.
All right. Let's go then to the next one. How do you control or be sure about the right anchor position when installation is made from a floating platform?
Yes, it's a good one. It's not that easy because you can't scan. When you are in the water, it's difficult to scan. So often we do from the top surface. Means we attach a mooring line and then a buoy at the top surface. We ensure that the buoy is sinking slightly to ensure that it's a vertical point. And then we put our device, our GPS device, on the top of the buoy. Then we can calculate what is the height and also the position, the X and Y position of the buoy. So this is basically how we do. Yeah.
All right. So next one, we have a question on, so we experience very high variation in water level in big reservoir. Generally, what is the maximum variation for which you have the anchoring and mooring solution available?
I will say we already did more than 35 meter water level variation. So this we know how to do. I think there's not much limitation. It's more a question of cost. That's always what is a bit tricky, is that we need to face the competition against ground mount often. You need to be at cost. And so everything's possible. It's a question of cost behind. So yes, we can go for more than 35 meters water level variation. We have different techniques to handle it. It could impact, I think, the maximum capacity you can place on the top surface. I mean, on the surface of the water. because if you don't fix it when water level is going down, means the array will move and then it will consume more space. So means it will reduce the maximum capacity you can place on the water surface. So yeah, it could have significant impact, but it needs to be studied really. There's no limitation.
Okay, thank you, Stephane. Then a question on, is there a standard to calculate, the possible waves that can occur in the lake, in the lakes?
Yeah, this is what I was explaining. Yes, and this we always do the calculation when we have more than 100 meters or 200 meters fetch distance between the array and the shore. And so we do this analysis to understand what is the wave applied on the array. So yes, we have to do it, and the waves could happen quite fast, especially in typhoons area, like what we are doing in Japan, Taiwan, even Philippines. We are working in project Philippines. So yes, we do proper analysis to understand what is the maximum wave height, the wave length, and the frequency also, because frequency will have a big impact on the fatigue of the structure. So yes, it's needed when you have big sites. It's needed to carry such analysis. Yes.
Okay, let's change now. This time it's more like, do you have any lessons learned to share from the Indian, so sorry my pronunciation, Omkareshwar wind damage? And was this avoidable from your side, you think?
Yes. You speak about the damage. First, I would like to say that our competitors was facing damage. I don't know about the damage the person is speaking about. So yes, there is a damage. It's not on our side. And yes, as I told, to avoid significant damage and damage during the installation, you need to act fast. Is what I was trying to explain before. You should not keep one array under construction for a long time, because you have only temporary mooring line, so limited numbers. So you are at risk. So you need to act fast to avoid such issue during construction time. Also, you need proper temporary mooring line, and to secure it, you need to check the weather forecast. If you see that there's winds coming in 1 or 2 days, you need to quickly try to secure as much as possible the temporary array. And yes, acting fast to connect all the mooring line, all the anchors to avoid temporary anchoring.
Okay, so many questions. Let me go to. So let's go to that one, which is, what is the solution of heavyweight equipment such as inverter, IDT, and megawatt scale project?
Yeah. We recently installed our new barge where we place central inverter. So we have dedicated barge. So it's not on the structure of the panel, the PV panel structure, but it's a separate barge, which is located only a few meters from the array. And on that we can install, I think here we installed more than 30 tons of equipment. So we do have this solution with a specific FRP design with fibers, and also we have a specific design of the float to minimize the acceleration we have when we are facing big waves. So yes, we do have a solution, and also we have solution for string inverter. So we have supports which are installed on the array, on the floating structure. So we have support to place a string inverter. Yes.
Thank you. So also now it's like, does your product work if the lake has to be emptied completely, and then that it does have to touch the sea ground?
Yeah. Yes, we did. I think we did 5 to 10. I don't know exactly, but at least 5 projects like this. We have big projects in, for instance, in Taiwan. Like we did 300 megawatt project. It's in a lagoon, and we are facing a tidal. So every 12 hours, it's landing on the ground. It's a sand, bottom. So it's quite soft. So of course we need to analyze what is the, the configuration of the bottom of the reservoir. If it's a bit rocky, if it's a sharp rock, you need to remove. But yes, our system is flexible, and that's why we can do this type of project. But we need to ensure it's soft landing. It's soft and it won't damage the float. It won't punch the float. This we are doing. So yes, once again, we have to study the site. But yes, with our solution, what we call hydroelectric solution, it's a flexible solution, so we can adapt to the small deviation you have on the ground. So yet that's possible, and we did. We have good experience on that, and we never faced any issue on those projects.
And then is there also a standard to calculate the possible waves that can occur in the lake? Or it's
standards, right? Standards.
Yeah.
I don't know much. No. Now we do simulations. There's some people, I mean, agencies which are familiar with those simulations, and so you can. I think it's not too complex to find people to do that studies. However, still, I would like to say that we see many differences. We used to do it to different vendors, and we see big differences in terms of wave height and wavelength. So with the same data, there's a different way of calculating the maximum wave. So once again, it's about what you consider for your simulation. So depend how you do the calculation. So it can give different results, because it's quite, there's different vendors for that. So we can drop you a few names if you want.
Thank you. Then in terms of safety, how do you deal with dam safety?
Oh, yeah, it's a good one. Actually, here today I was speaking more about the technical aspects, not about the development part, because I know it's a question that now the hydro dams owner are asking. So for now, we never faced any issue like this, and we don't act as a developer, and so it's difficult for me to tell exactly how the developer are dealing on that point. For now, often we are not always close to the dam. Depend if you are really near the dam. Yes, I think could be a concern. If you are a bit more far from the dam, and if the maximum the wind direction is not going in direction to the dam, so I think the risk is limited. For sure, you need a good design. You need a good design to ensure this to drift away and to be smashed on the big wall. It's a relevant question. It's a big concern. For now, we never faced such a issue, and we are full confident about our system. But I do understand the concern. I think we need to do proper analysis and to ensure any damage won't happen. Yeah.
And then final question, I think, for this webinar. Would you ever approve designs with aluminum cables rather than copper?
Yes, of course. We try to save cost always, and the copper is much more expensive. I think it's like 3 or 4 times. So, of course, we want to avoid copper. Actually, if we look at the track record we have, I think it's like 95% of the projects are made with aluminum only. So of course, this could have an impact on the fatigue because you have bending, many cycles of bending. So it depends how you fix the cables on the structure. So you need to have specific fixing system. So we can advise you how to do it. We have solutions. And more in Ciel Terre, we also take care of the scope, the installation scope. So when we do that, we also take care of the cable here. So yes, for now, the industry is using aluminium. Copper, for sure, when you have significant waves and fatigue, for sure it's better, but is the project allow that? Is it working on the economics? That's one question. Of course, I will advise it's better, but after this question of cost. Yeah.
All right, thank you very much. Thank you, Stéphane, for this very insightful presentation and answering all of these very technical questions as well. Thank you everyone for joining. I just want to remind that we have the floating conference happening the 19th of September. Some people are also clapping their hands to thank you, so very nice. You have a 20% special discount. You will receive that by email as well, because you will get access to the slides afterwards. Ciel Terre will also be with us at that one. And then, yeah, I also want to thank all of you. And thank you, Stephane, again for this presentation. And we see you.
Thank you, everyone. Thank you for your time, really. Be free to reach us. We'll support you.
All right. Bye-bye.
Thank you. Thank you. Bye-bye.